Hello. This is the E101 Section 2, Group 17. We are packed projectiles, and we made a precision launcher. So our team consists of me. My name is James Garman. I'm studying aerospace engineering.
I'm Tyler Arnold. I'm also studying aerospace engineering.
I am Jordan Gonzalez, and I'm also studying aerospace engineering.
Hello, my name is Francisco Gonzalez Rodriguez. I'm a freshman at NC State studying biomedical engineering.
So for our project, we had to do research, and the two main things we had to research were aerodynamics, which is composed of lift, just the force underneath the projectile in the air, weight, which is the force that pushes down, that's exerted from the earth on the projectile, thrust is which is what pushes the projectile through the air, and then drag, which is any air resistance that inhibits that thrust. We also had to learn about energy, particularly what it is. It's work, which is a force time when it's a force applied times a distance. We had to worry about the conservation of energy and different forms of energy and the transfer of energy, which is basically because energy is always conserved, we had to figure out how to convert the gravitational potential energy of the weight in the air into kinetic energy, which would be the projectile launching through the air. And something we had to keep in mind, which is what is a zero energy state, which basically means that beyond the potential energy in the system from the gravity with the weight, there had to be no initial energy in the system.
To create our launcher, we had to follow the 5-step engineering design process. The first one consisted of axing, and it was like axing ourselves what our launcher is going to do. The second one was imagine, and it's like imagine and brainstorm some ideas we have for our launcher. Third, we had to plan to make sure we get our materials and have the launcher done by the intended time. And then fourth, we had to create a launcher and test it to make sure it actually works. And then finally, we had to make improvements to create hopefully a better version.
So our initial design looked something like this. We designed it in SolidWorks. The way it worked is we had the weight at the top, it would drop, and that gravitational potential energy would be converted into elastic energy. We were going to be using elastic bands. We couldn't model them in SolidWorks. And then that elastic energy would be released. It would be stretched inside the PVC pipe, and then it would be released. And when the elastic contracted, the projectile would be launched out of the PVC pipe.
We did identify a couple problems with this initial design. The first was that we didn't have a confident design in a release mechanism, which would prevent our launcher from shooting entirely. We were also unclear on how to attach the bands in the PVC pipe without causing them to rub against the PVC pipe, possibly break. So in order to compensate for these two issues, we decided to rework our design using the same body and frame, but we replaced the elastic bands with string. This eliminated the need for a release mechanism. The idea was when you drop the weight, it would run the string through a series of loops that would pull a plate that was in the back of the PVC pipe up to the front, launching the ball out.
So our final design, we decided to go with elastic power. We scrapped our idea with a string. So in order to release the projectile, we opted to use a 3D printed release mechanism, and we also scrapped the PVC pipe so that we could have more room to work.
So this is just a video of our projectile being launched.
And with our final design, we found that there was a lot of room for improvements. We think that we should have used better materials and utilized pulleys instead of the screw eyes to account for friction. And the construction of the launcher itself could have been better.
As far as advice to future E101 groups goes, our number one point was time management. We feel like we could have started on this project earlier, which would have prevented cramming later on.
The second thing that we wanted to focus on for future E101 groups is utilizing the engineering lab. We found it extremely useful. It had most of if most of the things we needed were in there already, all we had to do was assemble them. One thing to keep in mind though is that you're going to want to sign up for times as sooner rather than later because they do fill up quickly, especially as Fed day approaches.
The third thing that we recommend is to make sure you guys have communication with team members. It's important to, with scheduling meetings, to keep pace of deadlines and actually building the project.
Having a confident design helps a lot because it takes, or once you have a confident design, you don't need to start designs all over again.
And then kind of going in hand with point 4, don't be afraid to make changes. We obviously made a bunch of changes. Our final design ended up looking very different from our initial design, but that's okay. Because it's better for your project to work a little bit than not work at all. And these are our citations for our PowerPoint slides. Thank you so much for watching.